So next we're going to do 11.8. It's the final section in chapter 11, but we're doing these out of order. I'm going to go back and do 11.2 through 11.6 later. This is our last graphing related section as much. This is going to be on cylindrical and spherical coordinates. Some shapes are better in other coordinate systems. Like we can do this cylinder that is like a Coke can with the center of the can being along the z-axis, and I can write it in terms of x, y, z, or I can treat it as a cylinder in r, theta, and z. So this is exploring writing stuff. This section's on exploring stuff in other coordinate systems. Let's look at the cylinder. We can get from your trig, hopefully you remember your trig, a circle. We can try rewrite a circle as x equals r cosine theta and y equals r sine theta. And if we look at just the z equals 0 plane down here, we got the circle right here. Remember in 2D, when we have x and y like this, theta goes like this. It starts on the x-axis and goes towards the positive y-axis. So we're going to do that same setup here in our cylindrical surface here in 3 dimensions. We'll start along the positive x-axis, and theta opens up as it gets larger as the angle opens towards the y positive axis. Z is still a vertical height that it's not dependent on r and theta, so we just leave z alone. So we got x equals r cosine theta, y equals r sine theta, and z equals z. If we want to, that's going from, if we have cylindrical coordinates and we wanted to get it in terms of x, y, and z, if we want to go the other way, we need to like solve for some stuff. We've done this before. Z doesn't need to change. This is in trig. Remember, if we do x squared plus y squared equals r squared, we have a circle. And this is r squared cosine squared theta plus r squared sine squared theta equals r squared. We factor out the r squared, we've got cosine squared theta plus sine squared theta. And recall that value equals 1. So x squared plus y squared equals r squared. I didn't need to write that while I was doing this. We know this equals r squared when we work it out, go through the process. So r is the square root of those. And we know this from trigonometry. Also, you should have learned in trigonometry to get theta, we're making a triangle right there. And theta equals tangent inverse of y over x. So we can convert back and forth between cylindrical coordinate systems and the Cartesian coordinate system or rectangular coordinate system as we wish. The only restrictions, we don't want theta to go over 2 pi, so let's restrict theta between 0 and 2 pi. And clearly a negative radius doesn't make sense, so we need r to be greater than or equal to 0. Let's look at some examples. Let's rewrite in the other coordinate system. So if I've got 1, comma square root of 3, comma negative 2, this theta, I guess that could be theta, but this is going to be looking like our Cartesian coordinates. So z stays the same. If I do r squared equals x squared plus y squared. So 1 squared plus root 3 squared, I've got 1 plus 3 is 4. The square root of 4 is 2, so I've got a radius 2. Theta equals tangent inverse of root 3 over 1. We get pi over 3, and I write that down in units, is radians. So in this coordinate system, in the cylindrical system, we've got R, theta, and Z. And that's the order we put them in. When we put them in parentheses, we've got R, theta, and Z, or X, Y, Z, of course. But we do R first, then theta, then Z for cylindrical. Let's look at going the other direction. Let's start with X equals, or we got 4 pi over 2 and -1. This will be our cylindrical coordinate system. And I've got, if I do X equals R cosine theta, and we got Y equals R sine theta, that's where I'm getting those. I plug them in, I've got 4 cosine pi over 2. Cosine pi over 2 is 0, so X is 0. If I plug in sine pi over 2, I get 4. Or sine pi over 2 is 1. 4 times 1 is 4. And Z remains the same. So we've got 0, 4, -1. If you've gotten a little bit lax in your trigonometry skills, you can look at my other YouTube channels, or you can look over your old notes. I do have stuff on trigonometry. I got full videos. They're not short clips like this section is. You can thank Benjamin for making these short videos. He told me flat out, if I'm going to do videos, they better be short, or he's going to give me hell and high water. And it makes sense. It takes more work in the beginning, but I did it. Let's see what else we got in this section. Let's look at converting an equation to the other system. So I've got Z squared equals X squared plus Y squared. This is one of the things I had sort of given you in the other video. It's a circular cone opening up and down. But let's rewrite this in coordinates, in the cylindrical coordinates. So if I do that, I plug in R cosine theta for X, R sine theta for Y, Z stays the same. I get Z squared equals R squared cosine squared theta plus R squared sine squared theta. We factor out the R squared, and we get Z squared equals R squared cosine squared theta plus sine squared theta, which is 1. That's a trig identity. So we're left with Z squared equals R squared, and thus Z equals plus or minus R, which means the radius of the circle is dependent on how high up or down we go. If we're at the 0, when we're at Z equals 0, there's no radius, we've just got a point. As we go up, the radius is related to Z. So when R equals, or Z equals 1, we've got a circle of radius 1. When Z equals 2, we've got a circle of radius 2. And it does the negative version as well. We did this same thing in one of the previous videos, but I had Y, we were doing it along the Y squared axis, going the other way. So there are ways to do cylindrical if you want to try to change the axis, treat Y squared or Y as your Z axis, and do a cylinder going sideways. You can, the formulas change a little bit. For a quick, nice little summary of what the formulas are and the other formulas in this section. This is on page 730 or 736 in your book. It's table 11.8.1. Let's see, where does it say 736? I think it's at the top of the page. 736. You go to the bottom of page 736. We have a table for conversion between rectangular and cylindrical, rectangular and spherical to cylindrical. We will explore the spherical stuff in the next video. Ta-ta!